Hey everyone, this is Shane Smillian, and I'm going to be giving an introduction now into components of vectors. How do we, and this is dealing with how do we break down vectors into their x and their y components, and why do we do it, and what is the most systematic and predictable way to do this to get outcomes when we're adding vectors. So anytime we're dealing with vectors, the very first thing that you need to do is you need to define your axis system, your coordinate axis system. So if you take a look here, I have a little x and a y here. You can see that here, and I've defined that, and I'm basically saying this. I'm saying that anything to the right is going to be positive in the x, and anything up is going to be positive in the y. And you might think that that's pretty much obvious, you know, that you don't need to define that, but in reality you always need to define your axes, because depending on the problem, I might want to make the positive x to the left, I might want to make the positive y down. It really just depends on the problem. So when you're dealing with something, for example, let's just say I have a vector here, and that vector is just floating around. Let's say it's in outer space. How do you know which way is up? How do you know which way is down? How do you know which way is left? How do you know which way is right? You don't really know. Okay, you don't really know if this vector is floating around in outer space. So what we need to do is we need to begin to give this some structure. So what I do is I take my vector. Let's say this is a vector of 20 meters here. Okay, and I start to define it along a coordinate system. Okay, so I start to define it. So now I've defined my coordinate system. My positive x is to the right, my positive y is up. I'm defining that. I'm saying that's the positive direction. And so now I begin to have some type of a reference point for this vector, and I can begin to break this down. Now, the reason we need to define the x and the y for vectors is because this is the only way that we can break it down and add up the components. If you notice, this vector is not along the x completely and it's not along the y completely. It's got a little bit of both, right? There's a little bit of both things going on here. And so the reason that we need to define these axes is that I need to take the part of this vector that runs along the x and find it, and I need the part of the vector that runs along this y and find it. And so we're going to do that in a minute. And it's very important because, like I said, you cannot just add this vector 20 like this. We have to resolve it along the y and along the x. So think about this. If this was like a language that you understood, you can only understand the language that's along the x and the language that's along the y. You don't understand this language here, okay? And we need to convert it into a language that we understand, which is the x and the y. And so one of the first steps in doing that is defining our coordinate system, which we did. And we just said that this is the positive direction here, so we know that this is my positive x here, and this is my positive y here. So the next question is this. I know that it's between them, but there is now an angle between them. So I could either define that angle here, I could define it from here to here, or I could define that angle from, I could define it from here to here if I wanted to, let's just say. So which one do I use? Well, the answer is that either one is correct, but one of them is used most of the time. And when I say most of the time, one of them is used as the default method in physics. Okay, so it's not to say you can have an angle to the vertical, you can have an angle to the horizontal, but what we want to use in physics is the angle to the horizontal most of the time. So these two angles make up the complement to each other. So what I'm going to show you here is, let's just say that I'm taking this angle here and I'm going to define this angle. And let's just say that this angle, you know, right now it looks like it's, you know, going a little bit more than 45. So let's just say that I made that angle, let's just say I made it 50 degrees here, okay? This angle right here would be the complement to that. And so this one, if I call that alpha, this would just be 40 degrees. So they're going to add up to 90. Okay, but which one do I use? In other words, I'm going to try to resolve this vector into its components, and I have to make a triangle. And you know, obviously I could make a triangle in two different ways. I could make a triangle this way. Okay, in other words, I can make a triangle this way, or I can make a triangle this way. But really what you want to do is you want to make the triangle along this axis. In other words, you want to drop that to the horizontal axis. Okay, that's the default. I'm going to show you why in a second. So I'm going to show you this. This vector actually has different components here. And you know, I'm going to show you the two different components here. I have a y component like this, and I also have an x component like this. So I'm just making these different colors so you can see them. So this is my x component here, this is my y component here. Now once I find these components, right, I'm going to be able to add up these components and add up these components with other vectors. So going back to choosing this angle here, we want to always choose this angle here because this is the default. In other words, I could have made this triangle like this. I could have made it like this and like this, right? If I made it like that, though, my reference angle is now 40, and in general we want to keep our triangle, we want to drop our vertical line down to this horizontal axis like this x-axis. That's the default, and I'm going to explain to you in a few minutes why that's important. Because we want to keep every time we're doing something, we want to have a default way that we do it all the time. And we're going to learn in a little bit, you know, just like in pre-calculus or trig, when you start to see the unit circle, everything is defined in relationship to this horizontal axis or the horizon. In physics, we will call this the horizon. So this is a really important concept here, because when we're talking about angle of elevation or angle of depression, we're talking about the horizon, okay? And most of the time, this is important in terms of defining the vector. So what I'm going to do right now is I'm going to erase this, okay? And I'm going to talk now about the signs of the vectors. So let's just say that this is a vector here. This vector is vector A, okay? This is a displacement vector A right here, okay? And that's 20 meters. And I have the x component of this vector, like this. And I have the y component of this vector now, like this. And so this makes a 90-degree triangle, right? So that's important. We'll learn about that in a little bit. Now, this x component here, it has a sign, right? Is it positive or negative? Is this x component positive or negative? The x component here is always going to be positive because it's along the positive x-axis. I hope you can see that. It's in this positive direction. And this y component here, you can see that it's positive because it's running up along this y-axis in this direction. So that's the first thing. What about the hypotenuse? What about this guy in here? What about the magnitude, right? This is the magnitude. Well, this is always positive. When we're talking about the magnitude, we always make it positive no matter what. So that's always going to be positive. But in this case, I'm taking a positive x and a positive y. Now, one of the reasons we choose to drop this always to the horizontal axis is simply because when I'm dealing with the components, I have to use trigonometric functions to find out the x component and the y component. But there is a default method when you drop it to the horizontal axis like this. And the default method is this, that the x component is always going to be the magnitude, which is 20, times the cosine of this angle, 50. Okay, so that's always going to be true. If you drop it, the x is going to be the cosine. So you don't have to go through the whole SOHCAHTOA every time because we know that the x is going to be the cosine. The y is going to be the sine. So the y component is going to be 20 meters sine 50. Okay, and that's going to be the positive component. So this is the x component, this is the y component. Now everything in math you're going to learn is alphabetical. So if I have x comma y, okay, you're going to see in vectors later on, we're going to have components that are going to be I comma j, and again that's alphabetical, okay? And so the I is the x, the j is the y, and in this case we're going to have cosine and we're going to have sine. Again, alphabetical, okay? This right here, if we run a line down, okay, if we run our line down right here, you can see that everything on this side was a little too much there. Let's go with a thinner line here. Everything on this side here is the x values, and they all kind of run together over here. You can see these are all the x values, so x, I, and cosine, and over here these are the y values, y, j, and sine. So in general, we want to always keep that default in physics. So again, the x is always going to correspond with the cosine and the y with the sine, as long as the angle that we have here is to this horizontal axis right here. So that's the default. Now, 90% of the time we can choose what to do with that. Okay, we can choose to make that to the horizontal, even if the problem gives it to us in the vertical. There are exceptions where you're going to have to use the vertical, like if the problem asks you to give the reference point to the y-axis, or if you're dealing with like a pendulum and the angle is to the vertical. So for example, if I had like a pendulum right here swinging, right, and this was my axis, right, and I had a pendulum and it was just swinging back and forth. Let me see if I can draw a pendulum here. So here's my pendulum swinging back and forth on a rope, let's just say, and let's just say that this is the angle that it's swinging at. Then I might have to deal with the vertical here. Or another example is if I'm on an inclined plane, we have to switch a lot of times to the vertical. But you know, most of the time in physics, you can control what you want to do. So drop it to that horizontal axis, and you're always going to get the x component's going to be the cosine, and the y component's going to be the sine. So that's pretty much a default that most people in physics use. Now, I'm going to show you very briefly here the concept of reference angles and how you pick the signs of the components. I'm going to review this going down here. This is dealing with the unit circle, and a lot of times we have these are all the possibilities that we could have for some type of a triangle system drawn on all of the different axes. Let me move this down a little bit here. So let's just go back here again. Let's redefine what we're talking about. Now I just want to talk to you about just the concept of what are the signs of the components. Okay, so typically we would say that this is quadrant number 1 right here, this one over here, right? This is quadrant number 1. This is quadrant number 2. This is quadrant number 3. Okay, and this is quadrant number 4, like this. And a lot of times you will also see a compass labeled like this: north, south, east, and west. Okay, so depending on the problem, it may ask you for the x and the y axis, or it might ask you in terms of north, south, east, and west. It doesn't really matter. It's the same concept. So the 0 point, when we're talking about an angle, the 0 point is really going to start here. This is 0 degrees, like this. A lot of people ask me, well, why does it start there? And why does it go counterclockwise? Because it does. It goes in this direction, right? And so, because think about it, like a clock would start up here, right? This would be 0, and a clock would just go clockwise. So this is really strange. This starts on the horizontal axis, okay, and it runs counterclockwise. And the thing I tell people is, well, think about how does the sun rise? Okay, the sun's rising in the east, right, in the morning. Because again, this is our standard definition of a horizon, right? This is a horizon. And again, this is going back to a fundamental concept of physics, a horizon. The sun rises in the east, it reaches its pinnacle above, okay? It sets in the west, and then during the night it goes underneath the earth. So this is just a way you can remember that. I mean, it's just, and again, it sets the example again for our horizon here, okay? So if I'm going from here, if it's at 0 and this is up here, this is 90 degrees. This is 180 degrees. This is 270 degrees. And this is 360 degrees. Okay. Now, typically we go around like this. So I can define vectors in many different ways. But the first thing I want to talk about is I can draw the same magnitude. Let's just say that I had a magnitude here. Let's say I had this vector here of, let's just say I had 100 meters here. 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 Okay. Now, that same vector, I can give the same reference angle for all of them. Okay. I can give the same theta for all of them. Okay. Reference angle, theta, 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 theta. Okay. So let's just say that my theta here was 30 degrees here, 30 degrees here, 30 degrees here, or 30 degrees here. So you see there's 4 alternate possibilities that this vector could be sitting in, right? I mean, this could be in different places. So this is my vector. I'm going to just draw a little arrow here, little arrow like this, just to show that that is my vector there. So I got 4 of them, right? So we talk about, a lot of times we talk about vectors a lot of the times as a magnitude and a direction, right? Well, here's a magnitude and here's a direction, right? Here's an angle. But that's not enough. We have to give a reference point, okay? So we're going to learn that with vectors, we either say this vector here is 100 meters, 30 degrees where? There's 4 of them, right? Well, this one's 30 degrees above the positive x-axis. This one's 30 degrees above the negative x-axis. This one's 30 degrees below the negative x-axis. And this one's 30 degrees below the positive x-axis, right? So again, when you're talking about vectors, I always like to say you need not just a magnitude and a direction, you need a magnitude, an angle, and a reference. Okay, so magnitude, an angle, and a reference. Okay, so if you can remember that MAR, okay, for short, like this, MAR for short, magnitude, angle, and reference. Okay, so let's just do an example here. Let's talk about this first vector here. Let's just label them different vectors. I don't know, let's say this is vector A. Let's say this is vector B. Let's say this is vector C. And let's say this is vector D, like this. Okay. So let's say that I was giving vector A. Well, let's talk about vector A here. Okay. So vector A, down here. What is the magnitude of vector A? Well, the magnitude of vector A is 100 meters. What's the angle of vector A? 30 degrees. And what's the reference of vector A? Above positive x-axis. Okay, see that? If I was talking about a compass, I would say 30 degrees north of east. So that's another way to say it. North of east. I'm sorry, north of east. So this is my reference. So magnitude, angle, reference, right? So when we're talking about a vector, that's important. You can't just say magnitude and direction. You could do an absolute direction with that. I mean, you could just you could give a direction that's just one big angle. Sometimes we do that, but I'll hold off on that for now. So let's say that that's A. Let's just do another one here. What would C be? Let's look at C. Let's go back here and see. Well, what's my magnitude of C? Well, we know that C is, I'm just picking one over here. Let's say that C here is 100 meters. We know that's the magnitude, right? Well, what's the angle here? Well, the angle here is 30 degrees, right? And what is my reference for C? What is my reference for C? If we're talking about this axis, it's below what? Below the negative x-axis. So I'm going to say below negative x-axis. Okay? Or I can say it is what? It is south of west. South of west. Okay, this second term here is usually the x-axis if we're talking about our reference angle being here. So this one was north of east, which is my x-axis. This one is south of west, if I'm talking about vector c here. Okay, so those are just a couple of examples, and we'll get more into that later in terms of how to label it. But you always need a magnitude, angle, and a reference. Okay. Now, one more thing I want to talk about this here. I want to talk about the signs of all of our components here, because that is really, really critical. So the signs of the components. So let's say that I have a component here. I'm going to use the same sign as my angle here. So if this is my x-axis here, right, positive x, right, when I get this vector, we know that the magnitude of the hypotenuse is always positive, right? Positive 100 here, positive 100 here. The sign of the magnitude is positive. Positive 100 here, positive 100 here. So the sign of all of the magnitudes is always positive, no matter what. But the question becomes, what do I do now for the signs of all of these individual components? Well, let's take a look here. Let's take a look at vector A. The sign of the x component here is positive. The sign of the y component here is positive. Let's look over at vector B. The sign of the x component is negative, right, because it's running along the negative x-axis. The sign of the y component is positive because it's going up. Now let's look at vector C. The sign of the x component is still negative, and the sign of the y component is negative, right? Now let's look at vector D. The sign of the x component is positive, and the sign of the y component is negative because it's going down, right? So these are the components of this vector here, right? So sometimes I refer to this as the bow tie, okay? This little, because it looks like a little bow tie, right? You see this little bow tie here? This little guy here, this little bow tie, can help you understand vectors very well if you can understand, first of all, we go back to the beginning, defining a positive x, a positive y, okay? Then you can define your negative x and your negative y. Then you can define north, south, east, and west, okay? Then you know that your 0 degrees starts here, and you go counterclockwise. So you start in quadrant 1 up to 90 degrees. You go through quadrant 2 down to 180 degrees. You continue going through quadrant 3 to 270 degrees. And then you continue going all the way back to 360 degrees or 0 here in quadrant 4. So that helps you understand where you are. These little guys in here, right, these are our reference angles. They're not the absolute angle. They're a reference angle because it's in reference to what? It's in reference to the x-axis here, or east, or it's in reference to the negative x-axis here, or west. Okay, so when I'm saying this vector here, it's above the positive x. Here's my positive x. I'm giving the reference, or I'm saying it's north of east. East is the x-axis. This one here, I'm saying it's above the negative x, or I'm saying that it's north of west. This one right here, vector 3, I'm saying it's below the negative x-axis, or I'm saying that it's south of west. This one right here, I'm saying it's below the positive x-axis, or I'm saying that it's south of east. Okay, and then finally, this little bow tie here is going to help you understand your components. So what is the sign of your component? Because when you're punching these numbers in your calculator, you do not put the negative, you don't put negatives in, you just put the reference angle. You just put 30, 30 all the time. So your calculator is not going to tell you the correct sign of these. If I put 30 in here, or 30 in here, or 30 in here, or 30 in here, these are 4 completely different vectors, right? So I need to understand on my bow tie, what is the sign? So I know for a fact, if I'm looking right here, that this one is always positive, this x here, this y is always positive. If I'm going over here to vector B, I know this x is always negative, this y is always positive. If I'm going over to vector C, I know this x is negative and this y is negative. And if I'm going over to vector D, I know the x is always positive and the y is always negative. So hopefully this gives you a nice introduction into the concept of vectors and components, and how and why we have to define a coordinate system, and then on that coordinate system we need to define how we're going to start from 0 going around, and then how are we going to define these reference angles within that coordinate system to help us define the correct sign of each component. Once we set up our whole system here, then we can begin to move forward and break down our vectors into components and begin to apply the concepts of vector addition. All right, that's all I've got for you right now on this video. I'm Shane Smiljan. Thanks for watching, and if you want to see any videos, please feel free to contact me and I'll upload any videos on physics that you would like to see. All right, I'll talk to you soon.